Hi guys, I couldn't get into my own meeting. I'm gonna get out and get back in. So there's some type of problem that I'm having, so I'm gonna get out and get back in. Okay, I think it's fixed. There's only one problem, other than you guys not having tech problems, is the teacher having problems. Okay. See me okay and hear me?
Yes.
Okay.
Yeah.
All right. Today is a very rough lesson. So everybody who is not here today they're going to feel like they're 2 weeks behind. There's nothing I can do about that. So I'll just continue to teach and people will get the idea of what's going on. Anyhow, happy Friday. Just a reminder about sending messages to me. Do not send me an email and a remind of the same message, because instead of having 40 messages, I have 80. So just send a message and remind if you need me for something, or if you're trying to say something to me. Also, if you look in Classroom, I put in resources, I put student help in there, because there's actually people at the high school. They're going to be helping students with various things. And so there's a bunch of information. If you look under resources for student help, if you need help with something, I put that in Google Classroom this morning. Okay. Lesson 1.3 is due tonight at 11:59. Today, I'm going to work 2 examples for 1.3, and then I'm teaching all of 1.4. All right, so make sure you take good notes and ask me questions if you have any. All right. The other day, I worked a problem from 1.3 where they gave you a graph and you had to write the quadratic function. So I'm going to do that problem again. And doing that problem again tells you something. It tells you better know how to do it, because it's going to keep coming up over and over again. So the problem I'm talking about is on page 38, example 2. So what they gave you was a bridge, and they said that A was right 2 down 20, and B was right 52 down 20, and they said that C was the vertex. So they said C was right 27 down 5, and since they said it was the vertex, that means H is 27 and K is -5. So the general form of a function is A times f of x minus h plus k. So that is not f times x. It's a special notation, f of x minus h. So this is just the general form. Now in this problem, they are specifically talking about a quadratic. And it's interesting because they leave off the b of the quadratic, which means b is 1. So if they leave something off like that, the only thing it can be is 1, because remember that 1x is equal to x. So we're to find a, b, h, and k. And we know that b is 1, h is 27, and k is -5. So a is what we don't know. So when we go to do this, we can pick any point we want. Don't pick the vertex. I'm going to pick this one because it's easier. So I'm going to pick right 2 down 20, and that's going to be my xy. So what I'm going to do is I'm going to evaluate the function at x equals 2. So that means wherever I see an x, I'm going to put a 2. There's your h. There's your k. Now, people are getting confused with this, and I'm not sure why, but this is a label, and f of 2 means y. So if f of 2 means y, y is -20. Now, if that's confusing you, we can put a y there, and then put -20 on the next step. So this would be -25 quantity squared minus 5. So I'm going to put my -20 in. So this would be 625a using the commutative property. I'm going to add 5 to this side and it goes away. And when I add 5 to this side is -15. And now I'm dividing both sides by 625. So a is equal to, when you divide the top and the bottom by 5, 3 over 125. So your new function then, and by the way, I want to call this g of x, because usually I call the form or the parent f. I like to call the new function g. All right, so g of x is equal to a times the quantity x minus 27 minus 5, and that's a square because it's a quadratic. So that's the function that models this problem, and the domain is starting on the far left at 2 and going up to 52. Okay, if you wanted to justify or verify your answer, that is a proof. And we would use the other point, B, right? 52 down 20. So that's another xy. So to prove that this is right, we could take g of x into our function. Wherever you see an x, you put a 52. Like I said, this is a label that means y. So this would be negative 3 over 125. This turns out to be 25 quantity squared. So now we put in our negative 20. And what we're doing is we're keeping the left side on the left side. We're keeping the right side on the right side and seeing if we can get a true statement. So this ends up being negative 3 over 125 times 625 minus 5. So this is 625 over 1. So when you cross cancel, 125 goes into 625 5 times. So you get negative 15 minus 5. So negative 20 equals negative 20. So we did prove that this function does represent this graph. And what I want you to notice here, see how all of these mean y? G of 52 means y means y, and y is also negative 20. All right, go ahead. Anybody have any questions? Now, if I were you, I would try to work this problem. So don't try another problem. Try to work this one and see if you can do this one correctly. Anybody want to ask me a question about it? Last call. Okay, I'm going to work one more problem like this. It's like I was saying the other day, these problems are going to be coming up in every section, so you have to know how to do this. It's not like, oh, well, you know, I'm just not going to do it and it'll go away. It's not going away. Now, you don't have to prove every time, but I was just showing how you can prove if you want to. So this problem is on page 40, number 13. And I'll read it. So it says, the netting of an empty hammock hangs between its supports along a curve that could be modeled by a parabola. So as soon as they say that, you know it's a quadratic function. And like I said, in this section, they're making B1 all the time. If B is some other number than 1, you'll know it. In the illustration, the unit of measure for both axes is in feet, and the vertex is C. So they're straight out saying that the vertex is C. They're saying that A is left 2 up 4. They're saying B is right 8 up 4, and the vertex is right 3 up 3, and that's also our HK. So we're going to find A, B, H, and K. Well, since there's no number there, we know it's 1, because if it was 0, it would be linear, not a quadratic. H is 3 and K is 3, and we have to find A. Now, sometimes in the future, you'll have to find B, but we'll wait till we get to that. So my new function G, I'm going to use the easiest point A to be my X and Y to find A. So we don't know what A is. And for X, I'm going to put -2. So wherever I see an x, I'm going to put -2 minus h quantity squared plus k. So like I said, this is a label, which means y. A negative and a negative is a negative, and you add. Y is 4. So this would be 25a plus 3. Subtract 3 from both sides would be 1. Divide both sides by 25. A is equal to 1/25. So your new function then would be 1/25. It's positive, so there's no reflection. It's a vertical stretch. Sorry, vertical compression by 1/25. And this would be what? X minus 3 quantity squared plus. So there's your function. The domain would be to the far left, -2. And it goes all the way to the right, which is 4. Eight. -2 and 8. And now we're going to justify or verify or prove. I'm writing different words here on purpose. So we're going to use the other point, which is 8, 4, and prove that this is right. So we're going to compute g of 8. So wherever you see an x, you're going to put an 8. And remember what I said, that's y. So I'm going to put the 4 in. And we're going to make sure that we get 4 is equal to 4. So this is 1/25, and this is 5 squared. Multiply that out, would be 25 over 1. You cross cancel because you're multiplying. So you end up with 1 plus 3. So 4 equals 4. So we did prove it. All right, that is lesson 1.3. It is due tonight. Hopefully you've done everything up to this point, and you just have to do these problems and you'll be good to go. All right, anybody want to ask anything before I go to the next lesson?
Where did you get B from?
Where did I get what?
Where did you get D from?
There is no D. Oh, the domain? The domain is, remember the domain is where the graphic is left and right. So the x is -2 and the x to the right is 8.
Oh, okay.
All right, anybody else want to ask me any questions about this before I erase it? Last call. Okay. This next lesson is inverses, and there's a bunch of things I have to teach before I teach the lesson. So this is lesson 1.4. and this is California Common Core Standard F-BF.4. And we're looking at inverses. Now, before I teach the lesson, I want to just show you what an inverse is graphically. So first of all, if I graph this line, right 1 up 1, right 2 up 2, right 3 up 3, 0, 0, left 1 down 1, this line that divides the coordinate plane in half is called the identity. Because whatever x is, if x is 10, y is 10. If x is 7, y is 7. If x is -8, y is -8. So what happens with an inverse is, let's say your graph is half a parabola. The inverse reflects over the identity. So if you folded your paper in half, you would find the inverse. Now, the inverse is the special notation, and it's read as F inverse of x. So this would be the function, that would be the inverse. And the inverse is a function because it passes the vertical line test. Now, you don't need to know this right now, but in the future, I'm going to tell you that this is the parabola restricted, and this guy is square root. So it makes sense that the parabola restricted inverse is square root. You don't need to know that right now. So let me show you another one. So that is a function. Doesn't have an equation, but there's your identity. And I don't know about you, but I'm not a visual person, so I wouldn't be able to do the inverse. So this is what you have to do. Watch. This point is right 4 up 3. This point is right 2 down 1. And this point is left 1 up 1. So to find the inverse, all you do is switch the x and y coordinate. So the inverse is going to be left 1 up 2, you just switch them. So left 1 up 2, it's going to be right 3 up 4. It's going to be, instead of left 1 up 1, it's going to be right 1 down 1. So see how the black graph, this little piece flipped this way and this little piece flipped that way and that piece flipped that way. So my identity's not drawing good, but that, see how it flips over the identity? So all I did was switch the ordered pairs. I switched the coordinates. All right, now you're going to find it interesting because when we find an inverse, we're going to be switching x and y. So I just wanted to show you what an inverse is, though. By the way, this black graph is an inverse, is a function, but the inverse fails the vertical line test. The inverse is not a function. So it's an inverse, but it's not a function, an inverse function. Fails the vertical line test. All right, so here are the steps for finding an inverse. Okay, the first thing you do is you want to, actually, you know what? I'm going to do this, but I'm going to save it for just a second. Getting a little ahead of myself. We're going to find the inverse, but I want to do compositions first, because compositions are going to be part of your problems, and I need you to be able to do this before I start the lesson. All right, I don't know if you had compositions in Algebra 1, but basically a composition looks like this. And the way it's read is f of g of x. So this does not mean f times g. It means f of g of x. And sometimes you'll see it written like this with a little open circle. So depending on what book you're looking at, it could look like that. So let's take a look at a problem. So that's a linear function, and they're giving you the parent of the quadratic, and I want to show you how to find an inverse. So if we wanted to find f of g of x, I'm sorry, we're not going to find an inverse, we're going to find a composition. What you do is you bring down the f and work from the inside out. So what is the g function? The g function, you're going to take that out and put in x squared. So now this is f of x. So now we're working with the f function, which is something plus 1, and the something now is x squared. So basically, you put in the g function. This becomes the x of the f function, and now you're putting that thing in for x in the f function. Let's do another one. G of f of x. So this time you drop down the g and you put the f function in, which is x plus 1. That thing becomes the x of the g function. Well, the g function is something squared. And the something would be x plus 1. And now you have to multiply this out. This would be x plus 1 times x plus 1, which is FOIL, x squared plus x plus x plus the last would be x squared plus 2x plus 1. So if you know the FOIL method, good. If you know the box method, but what you're doing is it's a fancy distributive property. You're multiplying two binomials. Did you guys have that in Algebra 1? Hello? Did you have the FOIL method in Algebra 1?
Yeah.
Okay, let's do some more. What if you want to do f of x? You bring down the f and you put the function in, which is x plus 1. That becomes the x of the f function again. So the f function is something plus 1, and the something now is x plus 1. So x plus 2 would be your composition. On this one, you put the g function in, which is x squared. That becomes the x of the g function again. which is something squared, and the something is x squared, so this would be x to the fourth. Okay, now we need to know how to do this to verify inverses. And so do you guys have any questions about how to find a composition?
Can you break it down? Because I don't understand this.
I'll do it in color. You work from the inside out. So see the g function? You take it out and you put in x squared. Do you see that?
Yeah, I see that.
All right. Now what you have is you have f of x. So now you're dealing with the f function. So the f function says to take something and add 1. Well, the something is x squared. Did you follow that or no?
Yeah, I'm following.
So like on this problem, f of x is pink. He becomes the x of the g function. Well, the g function is something squared. And the something is the pink. Do you want to do another problem?
Yeah, could we do another example, please?
So this time, I'll give you a linear function, 2x minus 1. And over here, I'll say the g function is x squared plus 2. So if I want you to compute f of g of x, you put the g function in, right? So the g function is that, right?
Yes.
That thing becomes the x of the f function. So the f function is 2 times something minus 1, right? 2 times something minus 1. And the something is now x squared plus 2. So what you get here is you get 2x squared plus 4 using the distributive property. So you get 2x squared plus 3. Are you good?
I think so.
Let's do another one. Last one. Put the f function in. That thing becomes the x of the g function. So the g function is something squared plus 2, right? Well, what's the something? It's 2x minus 1. And this is a lot of work. It's 2x minus 1 times 2x minus 1 plus 2. FOIL, 4x squared, outer would be negative 2x, inner would be negative 2x. Negative 1 times negative 1 is 1 plus 2. So your answer on this one is 4x squared. Negative and negative is negative 4x plus 3.
You lost me when you were doing the f of x.
up at the first step.
No, I get like how you distributed the G. So for, no, not the f of x. So it's f of x, and then you're going to, I'm lost for words, I'm sorry. It would be 2x minus 1, but I don't get what you did after that. That's what I'm trying to process.
I put it into the G function. See, look,
Oh, I
G
get it
of
now.
X.
Yeah, it just clicked. I'm sorry.
No, there's about 50 people that don't even know what I'm talking about right now. But if you don't ask me questions, then you got to figure it out on your own. So I haven't even started the lesson yet. So this isn't even the lesson. This is just what you should have learned in Algebra 1, compositions. All right, so we need to get this figured out because what you're going to see is way more complicated than this. So does anybody have a question about what I'm doing here?
Can you lower the computer a little bit so I can see the bottom of the board? Thank you.
You guys all know how to FOIL?
Ms. Birch, I have a question.
Go ahead.
Yeah, it's just, I'm confused about the f and the g of x, and basically like how many parentheses there are, and like the f parentheses g parentheses x, and then the twin.
Yeah. It's nested. So basically what you have is you have a function g of x, and it's nested in f. So it's f of g of x. So when I start the problem, I just drop the f down, and I work only with g of x. So g of x is x squared plus 2. After that, I'm dealing with f of x, but it's not f of x anymore. It's f of x squared plus 2. So in the f function, I have to take out the x and put this in its place. So the f function is 2 times something minus 1, and I'm taking that x out and I'm putting this in its place. Did you follow it or no?
Yes.
So think of it as it's being nested. It's coming from the inside out. All right, I'm going to start the lesson. So now you know what an identity is. And hopefully with practice, you can find a composition because that's how we're going to prove stuff. So the first thing I want to do is find an inverse. And these are the steps. The first thing you're going to do is change f of x to y. The second thing you're going to do is switch x and y. The third thing is solve for y. And the fourth thing is change y to the inverse notation, which is f inverse of x. So here's the first problem. It is linear. It's f of x is 3x minus 2. So we want to find the inverse. So change f of x to y, switch x and y, solve for y, so add 2 to both sides. When you add 2, you get x plus 2, and you're going to divide both sides by 3. So the last step is change y to f inverse of x, the special notation. It's just saying that it's an inverse function. So that's the inverse. Now we're going to graph. Okay, if I were you, I would draw the identity so you can make sure that your graph of f reflects over to get the inverse. And we're going to graph f of x first. So slope-intercept form. The slope is up 3, right 1, up 3, right 1, or down 3, left 1, and the intercept is 0, down 2. So start at 0, down 2, and go up 3, 1, 2, 3, right 1, go up 3, right 1, and draw the line. And that's the graph of f of x. Okay, the inverse is x plus 2 divided by 3. And that's a perfectly good answer. But when we're graphing, we like to write it in slope-intercept form. So you would write this as 1/3 x plus 2/3. So the slope is up 1, right 3, up 1, right 3, or down 1, left 3, down 1, left 3, and the y-intercept is 2/3. Now, that y-intercept, let me blow this up. 2/3 is between 0 and 1. So what this means is you would have to divide 1 into 3 equal parts, and this would be 2 out of 3 equal parts. So this is real little, but 2 out of 3 equal parts would be there. And from there, I'm going to go up 1, right 3, and I'm going to go down 1, which is negative 1/3, left 3, and draw the graph. Okay, that's an f inverse of x. And does it look like it flipped over the identity? So because I just did my identity freehand, my identity is a little off. So doesn't it look like it flipped over the identity? See this black part? Is it the blue? That black part looks like the blue. Any questions about the graphing? Okay, any question? Can I erase this? Because I'm going to show you the proof over here. Questions about the graphing? All right, to verify, what you have to do is take f of f inverse of x, the composition, and make sure that it equals x. And you have to take f inverse of f of x and make sure it equals x. Now, what I recommend is instead of using the inverse as f inverse, just write it as g of x. It's just easier to see. Now, you don't have to if you don't want to, but I'm letting f inverse be g. So, the first thing we have to do is f of g of x. So what's the g function? It's the inverse, right? And I would not use this one. I would use that one. So you're going to use x plus 2 divided by 3. That becomes the x of the f function. The f function, isn't that 3 times something minus 2? You guys with me or no?
What's the top word on the left, top left of the board?
Here?
No, top left.
Verify?
Yeah, verify. Okay, thank you.
Any questions about this right here? So now you put that in. And when you multiply fractions, you could cross cancel. So you end up with x plus 2 minus 2, so you get x. Now, this is what you're supposed to get. Can't get a 3, can't get a 0. It has to be x, and we got it. So because we got it, we're going to do the other one. You have to do both. So now we put the f function in, which is 3x minus 2, and that becomes the x of the g function. We're going to use that one again. The g function is your inverse, x plus 2 divided by 3. So when you put this in, you get 3x minus 2 plus 2, so those cancel. You end up with 3x over 3, and that is equal to x. So yes, these are inverses. We proved it.
You lost me on the third line for the g of x.
Here?
No, above that. Yes. So I don't get where you got the positive 2 and the 3 from.
This is the g function, isn't it?
Yes.
So isn't the g function something plus 2 divided by 3?
Oh, okay. Now I get it.
So now the something is the 3x minus 2. So those cancel. You get 3x over 3, which is x. So that's what you're going to be required to do. You're going to be required to find the inverse, graph both, and justify, verify, or prove that they are inverses. And you prove them by showing these two compositions to be equal to x. I'm only going to work one more problem with these, so if you have questions, ask me. No questions? This, by the way, has to be done exactly like this. So sometimes students will just write a bunch of garbage and write X. I do look at the work. The work has to look exactly like this. So this doesn't sway from this. This is the notation, and this is what the work should look like. All right, let's do one more of these. So a simple linear function, find the inverse. So you go through the steps, change f of x to y, switch x and y, solve for y, change y to the notation for inverse. The next thing we're going to do is graph both. I would draw the identity, which remember is right 1, up 1, right 2, up 2, right 4, up 4, and so on and so forth. So the first graph we're going to do is the function. So that is linear. So this is going to get worse, by the way, because these are going to turn into quadratics and cubics and everything. So the slope is up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, and the y-intercept is -1. So you start at -1, and you go up 1, right 1, up 1, right 1. Let me get this graph. F of x. Try to shove the inverse in here. So the inverse, because we're, the inverse is right here. F inverse of x is x plus 1, which means the slope is up 1, right 1, up 1, right 1, or down 1, left 1, and the intercept is 0, up 1. So we're doing up 1, right 1, or down 1, left 1. So these are actually parallel lines. We know that because the slope of the function is the same as the slope of the inverse. And whenever the slopes are the same, you have parallel lines. So this definitely does reflect over the inverse. So let's verify or prove or justify. So what we have to do is we have to take f of the inverse and make sure it equals x. And then we have to take g of f of x and make sure it equals x. So the g function is the inverse, which is x plus 1. That becomes the x of the f function, which is something minus 1. So the something is x plus 1. So that did work. And now we get the f function, which is x minus 1. That becomes the quantity for the g function, which is the inverse, so x plus 1. So something plus 1. And so the something is that, so that worked. So yes, those are inverses. We proved it. All right, questions?
Could you give us an example that we could work by ourselves?
You can work these by yourself. I'm not gonna have time to do that today. I'm hoping to give you time to work in groups, hopefully next week. But right now, what you have to do is you have to try to work the examples that I've done on your own. So what you're gonna do is pick one of the examples and work it. And then if you need help, look at my key.
Okay.
Okay? All right, I'm gonna do one more example, but does anybody want to ask me about anything before I it?
So Ms. Birch, so for the f and g of x, you're basically getting them from like the other side, huh? So since it's on the g of x is on the left side, or the f of g of x, you basically get the f of g of x on like the right side. You basically kind of
Hold on.
like
I'm working from the inside out.
Mhm.
So I'm not worried about F. I'm just letting F float down.
Yeah.
So what I'm getting is the G function, which is the inverse, right? So
Yep.
I'm coming over here and I'm getting the inverse, which is x plus 1.
Mhm.
After I do that, I'm not dealing with G anymore. I'm dealing with the F function. So now I have to come back over here and write down something minus 1. So that's why you saw me write this. That's something minus 1.
Okay.
And what I did, I put the real something in, which is x plus 1. Did you follow that or no?
Yes, I did. Not clarified.
Okay, anybody else want to ask me about it? All right, I'm going to do one more problem. So yeah, don't try to do any new problems. Try to work the problems out of my notes first, then try a new problem. Because if you can work the ones out of my notes, you can probably work a new problem. Okay, this is a word problem. The word problems are actually pretty simple. Let's take a look at it on page 51. Okay, so they're saying for the given function, state the domain using set notation, which we're going to use interval notation. And it says find the equation for the inverse and graph it, and then interpret what's going on. So they give you this. They give you C is equal to 3.5 G's. So what does this mean? Let's read the problem. It says this equation gives the cost in dollars as a function of the numbers of gallons of gasoline when the price is $3.50 per gallon. So this is really pretty simple. All you don't switch the variables with the word problems. All you do is solve for the other variable. So basically what you're seeing here is you're seeing the cost of gas in G's. We're going to find the gas in terms of cost. So when we divide both sides by 3.5, we get G is equal to C over 3.5, and that is the inverse. So we would just write gas in terms of costs now. So all you do is just solve for the other variables. So like I said, this is cost of gas. This is gas in terms of cost. here's what you're gonna do. You're gonna make a table. You're gonna input C, and you're gonna output G and get some ordered pairs. Now, if I put in 1 and 2, I get little numbers. So I'm just gonna put in like a 6. So can you do me a favor? On your calculator, tell me what's 6 divided by 3.5?
I got 1.71.
Okay, good. All right, how about 12 divided by 3.5?
3.4.
Okay, and then I'll go 6, I'll go 18. What's 18 divided by 3.5?
5.1.
Okay. So over here, when I do my graph, I'm going to make my X the cost, and I'm going to make my Y the gas in gallons. This is 0. Now, the reason why you don't see me doing any negatives, because it doesn't make any sense in this problem to have negatives, right? So look at my X's are going up by 6s. So I'm just going to do that. I'm going to go 6, 12, 18, 24. And on the Y-axis, I'm just going to count by 1s. So you would graph these ordered pairs. So you have 0, 0, right? Because if you put in a 0, you get 0 over that, which is 0. All right, now you're going to go right 6, up 1 7/10. So that's 7 out of 10 pressure. So we could just say it's close to 2, but we're going to go right 6, up close to 2. That's good enough. We're going to go right 12, up about 3.5. And you're going to go right 18, up 5. So that would be your graph. And they're asking for the domain in set notation, but we're going to use interval notation, and that would be from 0 to infinity. So they're asking, okay, fine, whatever. There's your function of gas in terms of cost. There's your graph. There's your domain. What does all this mean? Well, first of all, the inverse function gives the gallons of gas as the function, it's as a function of the cost in dollars. So basic, and what it represents is it's the price of gas, when the gas is $3.50 a gallon. So that's what this represents. It represents, the inverse function is the gallons of gas as a function of the cost. All right, I'm going to turn off the video. I hope you guys have a good weekend, but we're not leaving yet. I'm just turning off the video. All right, so let me turn this off. Okay.